Okay, this is tape 12, which is on polynomials. What we will look at is how to add, subtract, and multiply polynomials. Now, you should read the task booklet to understand what monomials are, and binomials, and trinomials, and so on and so forth. Make sure you read that chapter that's dealing with this. What I'm going to do is try to show you how to mechanically do the work. So let's look at the first problem in your notes. And what we're doing here is adding and subtracting, or adding and or subtracting. Whatever comes into the problem, if we have the plus sign, it means we're adding. We have subtraction sign or the minus sign, then we're going to subtract. Now, please listen to this statement. You can only add oranges to oranges, apples to apples, pears to pears, and so on. So what we need to do is understand that that is 3x. So the only thing we can add to x is another x. So here we have 3x plus 5x. So that adds up to 8x. Now again, I want to make a big deal out of the first few problems, then I'll get a little faster in working them. But I'm saying that this represents 3 apples plus 5 apples plus 3 oranges minus an orange plus 3 pears plus 2 pears. I cannot add an x squared, this thing, to this. This represents 3 times x, 5 times x, 3 times y, a minus 1 times y, 3 times an x squared. What does x squared mean? X squared means x times x. So that's a different breed of cat than this over here. So you cannot add things together unless all this letter part right here is exactly the same. So that means we have 3x and 5x. Do we have any other x's? No. So we'll add those up. Now we come back and look at the problem. Y's. Do we have any y's over here? No. So 3y minus 1 of the y's is 2 of the y's. Now going over here, we have x squared and an x squared. We have how many of them? 3 of them plus 2 of them. So that added gives us 5 of those. So look at that briefly and let me keep talking again. And that is, polynomials are things that have several terms. This is considered to be a term. So we're adding up many terms. But the rule is you only add x's to x's, y's to y's, x squares to x squares, x cubes to x cubes, x times y to x times y's. So you can only add apples to apples, oranges to oranges, pears to pears. All right, let's look at the next example and keep doing the same talk. The next problem, number 2, has parentheses around it. Now, what that means is simply remove the parentheses. To remove the parentheses, you multiply everything inside by what's immediately in front of it, which is a 1. 1 times this is y squared, and 1 times this is 4y. Removing the parentheses here, in front of it is a plus 1. So a plus 1 times this is a minus. And a plus 1 times this is a minus. Now, we add apples to apples, oranges to oranges, and so on. We have a y squared. Do we have any other y squared in the problem? No. Therefore, we just write that down. Then we have a 4y. Do we have any other y's in the problem? Yeah, we're going to add those. So what is a plus 4y and a minus 4y added? And that's 0. And then we have a minus 8 left. All right, adding apples to apples, oranges to oranges, pears to pears. All right, let's look at the next example, problem 3. All right, now at this point I want to start showing you two different ways of working these. Number one is remove the parentheses. All right, so it's 5x squared plus 4x plus 3. Removing the parentheses, it's a plus in front of it, so it's a plus 1. So that you just copy everything down. So the shortcut is, if you just have a plus in front of it, you just remove the parentheses. All right, now we add apples to apples. Well, we have a 5x squared and a 7x squared. And then we have a 4x and a minus x. And then we have a 3 and a 2. So adding the x squareds together, we get 12x squared. Adding the x's, we have 4 of them minus 1 of them, so that's 3 of them. And then the numbers, plus 3 and a plus 2 is a plus 5. So again, the process is remove the parentheses, and you do that by multiplying everything inside, everything. Multiply that and that and that by what's directly in front of the parentheses. Then add apples to apples, oranges to oranges, pears to pears. All right, let me erase this now and show you another way of doing a problem, which is just as efficient, and it's going to try to fit into when we do the multiplication of polynomials. And that is, do like a lot of times when you add things, you put one underneath the other one. So let's write down 5x squared plus 4x plus 3, and then write the other one below it. Put x squares below x squares, x's below x's, and numbers below the numbers. And adding, we get 12x squared. Adding, we get plus 3x. Adding, we get plus 5. This is just another way that might help you see it a little better. You just pick out which way you like to do it and do it that way. Don't necessarily work both ways. All right, let's look at the next example, problem 4. All right, let's do the writing one underneath the other one first this time. Let's say we're going to have 4x squared minus 5xy. And now we're going to put this one underneath it. Well, x squares go underneath x squares, so that's 3x squared. And the xy goes underneath the xy, so that's plus 6xy. And the y squared goes under, well, doesn't have a y squared up here, so you can put it anywhere. We could have placed it here, or we could have put it out in front. What the concept is when you add, you put apples underneath apples, oranges underneath oranges, and pears underneath pears. You've got to look at this as this is 5 of these objects. And this is 6 of these objects. And so when you add those, you add the numbers out in front of them. You do not add the x and y's. You add how many x and y's you have, and how many x and y's that you have. How many x squares do we have? How many x squares do we have? Well, we have 4 up here and 3 there, and so adding that gives us 7 of those. Here we have a minus 5 of these things and a plus 6, and so that adds up to be a plus 1. So we have a plus 1 of those. Now here we have 0 of these and a minus 4, and that added is a minus 4 of those. Okay, so that's one way of doing it. Now let's do the other way. Let's do it by removing the parentheses. So removing the parentheses, we have 4x squared minus 5xy plus 3x squared plus 6xy minus 4y squared. Now we come along and add apples to apples. All right, here's some x squares, and there's x squares, so that's 7 of those. Here's some xy's, and here's some more xy's, and we have a minus 5 of those and a plus 6. So a minus 5 and a plus 6 added is a plus 1 of those. And that leaves us just this, so we write it down. Okay, let's look at the next example, problem 5. Now in problem 5 and 6 and 7 and 8, the next 4 here, what we have is a minus sign out in front of the parentheses. So what we need to do then is say, okay, that means subtraction. Subtraction. Well, let's see. Let's do it by this method. If we write down the x squared minus 6x, and we're going to subtract x squared minus 10x. We're going to subtract this now. Now remember, subtraction, you do what? You change the sign of the bottom one and add. So now what is this and this added? What's a plus one of these apples and a minus one apple? It's 0. So that's 0. All right, and then what is a minus 6 and a plus 10 added, and that's a plus 4. So the final answer on this problem is simply 4x. Now let's look at the problem again. What this means is subtraction. When you subtract, you do what? You change the sign on the bottom one and add. Now that might be a little confusing, so maybe that's not the best way to do it. So let's learn the other way then. All right, that's removing parentheses. What's in front of this parenthesis? Just a 1, plus 1. So removing parentheses is x squared minus 6x. Now, removing parentheses. When you have a minus out here, that's a minus 1. What is a minus times a plus x squared? That's a minus x squared. What is a minus times a minus? That's a plus 10x. Now I understand some of this can be confusing because at one time you multiply and one time you add and subtract and so on. But that just means you're going to have to do a lot of practice problems. To remove the parentheses, whatever's directly in front of it, you must multiply that times everything inside. Now we add apples to apples. We have a plus x squared and we subtract an x squared. So that drops out. We have a minus 6x and a plus 10 of them. So that final answer is a plus 4x. All right, let's look at number 6. Just some more of the same work, but again, keep watching this and get the concept and the mechanical process drilled into you. All right. So let's remove parentheses. That's 4x cubed plus 5x plus 2. Now, removing the parentheses with a minus in front of it, you change the sign of everything inside. Minus times a minus changes that to a plus. Minus times a plus is a minus. Minus times a plus is a minus. Or other words, here's the shortcut trick. If you have a minus in front of the parentheses, to remove the parentheses, you change the sign of everything inside. Change the sign of each of the terms inside. All right, now we're ready to add apples to apples. Well, let's see. We've got 4x cubed here. Do we have any more x cubes? No. So we can't add that to anything. We'll just write it down. All right, now we have an x squared. We don't have any other x squared, so we'll just write those down. Now, I want you to notice I skipped over talking about the x because you're really supposed to write. Doesn't make it wrong, but you're supposed to write equations with the highest power first, and then the next highest power, and then the next highest power, and so on. You're supposed to put the letters in descending order of the powers. And alphabetically, if you have more than one letter. If you had y's in here, then you do all the x's first, and then y's. But it doesn't make it wrong when you're just adding things like this. All right, now we're to x's. So we come back here and say, okay, we have 5 of these, and over here we have a minus 2 of those. So 5 apples minus 2 apples is 3 of them. And then we add the numbers. A plus 2 and a minus 1 added is a plus 1. Okay. Notice what I'm saying is you just don't add the first thing to the first thing and the second thing to the second thing. What you do is add apples to apples, oranges to oranges, pears to pears. Well, we have an x cubed. You don't have any more of those, so you can't have anything to add to it. Write it down. Over here you have an x squared, but you don't have any other x squared. So you just write it down. And now you get to add x's to x's, numbers to numbers. All right, let's look at the next example, problem 7. Just same work. Okay, here we have 4a cubed minus 2a plus 1. Now, removing the parentheses with a minus in front of it, minus times, that's a plus. So minus times, that's a minus. Minus times, that's a plus. And a minus times, that's a minus. Or change the sign of everything inside. Change this to a minus, change this to a plus, change that to a minus. Now, add apples to apples, oranges to oranges, and so on. All right, we have a 4a cubed. Here we have a minus 1 of those. So 4 minus 1 of those is 3 of the a cubes. All right, here we have a minus 2 of these and a plus 2. Well, that drops out, adds up to 0. And then we have a 1 and a minus 3. A 1 and a minus 3 added is a minus 2. Now again, that is all there is to adding what's called polynomials. Apples to apples, oranges to oranges, pears to pears. All right, next example, problem 8. Okay, removing parentheses. So there's nothing in front of this parenthesis, so you just get to remove the parentheses. Just drop the parentheses. Now, you're actually multiplying by plus 1. Plus 1 times anything is just the same answer. Okay, over here now, a little different problem that we're going to work on in the next section of this tape. And we have a minus 2 out in front. Now again, if you follow the rules I've been trying to say, it still works. And that is, you multiply everything inside here by what is directly in front of the parentheses. So what is a minus 2 times a plus 2? And that's a minus 4 of the y squared terms. Now, what is a minus 2 times a minus 3? That's a plus 6 y's. And what is a minus 2 times a plus 3? That's a minus 6. So again, it stays by the rule that to remove the parentheses, you multiply by what is directly in front of it. So a minus 2 times this. Well, a minus still changes the signs of everything. This was minus, it changed to plus. This was a minus, a plus, it changed to a minus. The number in front of here just simply multiplies times the numbers. And now we're ready to add apples to apples, oranges to oranges. Okay, we have 4y cubed, don't have any y cubes, so we just write that down. See, we've got a minus 4y squared. And now we have some y's to add. We've got a minus y here and a plus 6 of them here. So that's 5 of those. And then we have a minus 1 and a minus 6 added is a minus 7. All right, now that's how you add and subtract what are called polynomials. Now let's look at the second page of your problems on this tape, and we'll learn how to multiply polynomials. All right, now we're looking at multiplication of polynomials. Now, I mean, it might be a monomial, might be a binomial, might be a trinomial. I'll start putting some of these words in here, but again, I hope you will always study the pages in the task booklet along with the videotapes. All right, the first one here in multiplication of polynomials, here is a monomial times a monomial. Let's forget all those words though, and here's what we do. To multiply, you multiply the numbers times the numbers. So what is 3 times 1? Well, that's 3. And what is y times y? That's y squared. Remembering now that you add powers here, or whatever you want to think. Y times y is y squared. That's what y squared means. Y squared means y times y. So that's very simple. But listen to the words. It is multiply numbers times numbers, letters times letters. Okay? The next example. Okay, here is term, multiply to term. Again, this is a monomial, one term times one term. Now, the rule is multiply numbers times numbers. 1 times 1 is 1. Letters times letters. X squared times x is x cubed. And y times y to the fourth is y to the fifth. Okay. X cubed means x times x times x. Well, that's what this is. Y to the fifth means y times y times y times y times y. 4 of them here and 1 there. 4 of them here and 1 there. So the shortcut rule is this. When you multiply letters times letters, you add the powers, the exponents. When you multiply letters times letters, you add the exponents. All right, look at the next example. Number 3. What is the rule here? Numbers times numbers. So what are minus 3 times a plus 2? That's a minus 6. Letters times letters. A cubed times a squared is a to the fifth power. And then b times, there's not a b over here, so that's just like a 1, so you just write down the b to the fourth. You're actually saying b to the fourth times 1, which is b to the fourth. So the rule is multiply numbers times numbers, and then when you multiply letters times letters, you add the powers. All right, let's look at the next example. Problem 4 is, there's no difference. There's no difference in this problem if I put parentheses around it. This simply says numbers times numbers. The number in front of this is a 1. 1 times 2 is 2. X times x is x squared. All right, next one, problem number 5. Multiply numbers times numbers. What's a minus 2 times a plus 10? That's a minus 20. X times x's. Here we have 1x, and another one of those, so that's x squared. Here we have y times y. We have 2, and 1 is 3, so we have y cubed. Y cubed means 2 y's times this other y. All right, next one, number 6. Numbers times numbers. So come down here and do 3 times a minus 2, that's a minus 6, times 4 is a minus 24. Now, a's times a's. There's a here and there, so that's 3 of those. A times a times a times a. All right, then the b's, we have 2 here, 1 more, so that's b cubed. In the c's, we have 1 here and 2 here, so that's c cubed. Numbers times numbers, letters times letters. All right, now let's look at the next set of problems. Now this, starting with problem 7, is what's called a monomial times a binomial. A binomial is where you have 2 terms added or subtracted together. But it goes with the rule of the first part of this tape, and that was to remove parentheses, you multiply everything inside. So what is x times x? That's x squared. What is x times a minus 2? That's a minus 2 times x. So to remove parentheses, you multiply everything inside by what's directly in front. X times x is x squared, and then x times a minus 2 is a minus 2x. All right, number 8. To remove parentheses, you multiply everything times what is inside. I'm sorry, everything inside but what's out in front, okay? So what is minus 5 times a 1? That's a minus 5. What is x squared times x squared? That's x to the 4th. There are 4 of them. You're not multiplying 2 times 2 to get 4. You're saying I have 2 of these x's, 2 more of those x's, which will make 4 x's. X to the 4th power. X times x times x times x. All right, now minus 5 times a minus 1 is a plus 5. And x squared times x is x cubed. Okay, let's look at number 9. Looking at number 9, doesn't make any difference whether it's on the left side or the right side of the equal. To remove parentheses, you multiply everything inside by what's right here. So 2x times 2x is 4x squared, because 2 times the 2 is 4. And x to the 1st power times x to the 1st power, you add the powers. Now, 2x times a plus 1 is 2x. 1 times anything is equal to that number, 2x. All right, now let's progress to a little larger problem, but same rule. Problem 10 is exactly like problem 7 in its process. To remove parentheses, you multiply everything inside by what's directly in front of the parentheses, or what's directly over here. Okay, so x times this, it's 1 times 2, so that's 2. X times x cubed is 4 of those. And then this times this is a minus 3, and x times x is x squared. And then x times this is plus 2x. All right, number 11. Number 11. Okay. Now, watch, starting to get a little more complicated. To remove parentheses, you multiply whatever's directly in front of it by everything inside. So, what is x? Y times x squared. Well, it's x times the x's, so that's x cubed y. All right, now we're going to multiply xy times xy. All right, number is 1 times a minus 3 is a minus 3. X times the x is x squared. The y times the y is y squared. X times x's, y's times the y's. All right, and the last one, this times this, is plus. It's a 1 and a 1. Now x, and then y times the y squared is the y cubed. All right, let's look now at number 12. Looking at number 12. Okay, we have a minus out here, and all that does is, when we remove the parentheses, it changes the sign of everything inside. Or, what is a minus times a minus? So that's a plus 2. And then a times a squared is a cubed. There are 3 of them. Okay, then minus times a minus is a plus 3. A times a is a squared. And then minus times a minus is a plus 2a. Again, when you have a minus out in front that you're multiplying, when you remove parentheses, it changes the sign of everything inside. All right, now let's move to 13, which is a lot more complicated. Now 13 is when you're multiplying a binomial times a trinomial or another binomial. So it's really a different type of problem. And what I'd like for you to do is the mechanical way to always get the job done is just to do it like regular multiplication. Now, I don't have this on your notes, but I want you to watch this. To multiply 123 times 45, you multiply the 5 times everything here. That would be 15. Carry your 1. That would be 11. Carry your 1. So that would be 6. Then you come down here and multiply the 4 times the 3 and place it underneath here. So 4 times 3 is 12. Carry your 1. It's 9. Place it underneath this, and so on. Okay? And then you add up the 1s and the 10 places and the 100 places and the 1,000 places. So in multiplication, It's the same thing. Algebra is nothing but the same rules of arithmetic. So what that says is we're going to write down x squared plus 3x plus 2, and then write this down underneath it. Put numbers underneath numbers, just like ones underneath ones, x's underneath x's, just like tens underneath tens, and x squares underneath x squares, and so on. And now we do the same process. We take this and multiply everything up there, just like regular long multiplication. So what's a plus 1 times a plus 2? That's plus 2. What's plus 1 times that? So that's 3x. And what's a plus 1 times that? So that's x squared. Now you come over here. This is just like where the 4 was a while ago. You now multiply this times that. That's 2x, and you put x's underneath x's. Then you multiply this times that. That's 3x squared. You put x squares underneath x squares. And then x times x squared is x cubed. And now you just add up. Adding these, plus 2. Adding these, plus 5x. Adding these, 3x squared. And then x cubed. And that's all there is to getting the job done mechanically. If you multiply this times that, you simply get to put this underneath it, and then just do like long multiplication. This times everything up there, write it down. Okay, then start here and multiply back here, and put x's underneath x's, x squares underneath x squares, x cubes underneath x cubes. All right, now that's the way I think you should do it just to get the job done. Let me show you another way, and if you like that, you may use this other method, but to me it's a little longer. And that's this. Using the rule to remove parentheses, you multiply everything inside there by what's over here. Okay? Well, what you do is do both of these. For instance, I'm going to multiply x times everything inside there. So x times x squared is x cubed. X times 3x is 3x squared. X times 2 is 2x. Then you're going to come over and say, okay, now I want to multiply everything by this part. So multiplying everything over there by plus 1 is a plus x squared. Plus 1 plus 3x. Plus 1 times 2 is plus 2. Now you go add apples to apples. Well, we don't have any x cubes anymore besides this one, so we write it down. And here we have x squared, add that up, we get 4x squared. We have x's, so we add that up, we get 5x's. And then we write down the 2. And so we end up the same answer. And you might like this method better. Just remember to remove these parentheses right here. What I must do is multiply everything inside by this and this. Then come along and add up apples to apples, oranges to oranges, so on. All right, let's look at number 14. Okay, and I'll do this one both ways. And since we ended up with that other method a while ago, let's just do it this way. I want to multiply everything inside by the x, so it's x to the 4th. This times that's a minus 3x squared. This times that's a plus 2x. Okay, now I'm going to take in this and multiply everything. So this times that is a minus 4x cubed. Right, this times that's a plus 12x. And this times that's a minus 8. Now add apples to apples. Well, we don't have any other x to the 4th. We don't have any x cubes. All right, so we don't have any other x squares, but now we get to add x's to x's, and that's 14 of those, and then the number 8. All right, now if we had done it the other direction, and again, what I think you should do is pick out one of these, know how to do it that way, and just use that one. Don't necessarily work both of them. What we do is x cubed minus 3x plus 2. Write this down underneath. The idea that this works is it's a pretty nice deal if you have a trinomial times a trinomial, okay, or complicated multiplication. All right, here we go. This times that is minus 8. This times that is a plus 12x. This times that is a minus 4x cubed. All right, now, this times that is a plus 2x. This times that's an x squared. Do not come over here and put it underneath this. This is x cubed. That's an x squared. So that's a minus 3x squared. I just go write it somewhere else. But don't put x squares underneath x cubes. Put x's underneath x's, x cubes underneath x cubes, numbers underneath numbers, and so on. All right, then this times this is x to the 4th. Well, we don't have any of those, so we'll have to put it over out here in front. And now we add up the numbers. X to the 4th, adding this to 0 is just that number. Adding this, we get the 14x, the 8, and the minus 3x squared. And so rearranging this, we get the same answer as we had by doing the other method. So just pick out one of these methods and work the example problems and do that. All right, let's look at some more examples. All right, looking at number 15, here's one of those I talked about trinomial times trinomial. And so one way of working this is to write this one down and put this directly underneath it. So we go this times everything. Minus times that's a minus 5. Minus times that's a plus 6x. Minus times that is a minus x squared. All right, now we take this and multiply it times everything. Okay, this times that's a minus 15x. This times that is a plus 18x squared. And this times that is a minus 3x cubed. All right, then we come along and we multiply this times everything. This times that is 5x squared. Well, x squareds go underneath x squares. And then this times that is a minus 6x cubed, so that goes underneath the x cubes. And then x squared times x squared is x to the 4th. And now we come back and add. Okay. Adding this is x to the 4th, adding x cubes, minus 9 of those. Adding this would be 18 minus 1 would be 17, plus 5 would be plus 22 of those. And a plus 6 and a minus 15 is a minus 9 of those, and then minus 5. Okay, and so that gets the job done. And that's probably just as good a method as going back up here, and I'm not going to do it on the tape, as saying this times everything, and then this times everything, and then this times everything, and then adding the x to the 4th to the x to the 4th, adding x cubes to x cubes, adding x squares to x squares, adding x's to x's, and numbers. All right, now what I want you to do is to change gears, look at 16, and we're going to learn a special way of multiplying binomials times binomials. And the reason that you need to learn this method is it's going to help you in the next tape on factoring. If you need to watch the tape on factoring, if you need to know how to do factoring, then it's very crucial that you learn this particular special method when multiplying a binomial, two terms in here, times a binomial. And what we do is we call this the FOIL method. Okay, this is the FOIL method. And what the FOIL method says is the first times the first. Okay, so we're going to do the first times the first. That's what the F stands for. So the first times the first is 15a squared. Then the L stands for the last times the last, and that's a minus 8. And then the O and I stands for inside-outside. So we're going to multiply the inside, that's 10A, and the outside, that's minus 12A, and we're going to add those up, and so we get a minus 2A. Oops, that's a brand new concept, isn't it? Well, let's start all over again. The FOIL method says multiply the first times the first, first times the first, last times the last, outside times the outside, inside times the inside. Now, it doesn't mean that you do this necessarily in special order. Doesn't mean that you have to do this one first or this one. It just says that to get the job done, you're going to do these 4 things. You're going to multiply the first times the first sometime. You're going to do the outsides multiplied together. You're going to do what's on the inside multiplied together. And you're going to do the last times the last. But the way I try to teach it and the way I work it is this. I do first times the first, write it down. I do last times the last, write it down. And then I do the inside plus the outside. Now, the reason that some people have written it this way is to try to get you to remember first times the first, last times the last, inside, outside. All right, let's look at number 17 and do the rule. Okay, 17, first times the first is x squared, last times the last, plus 3, inside is 1, outside is 1x, outside is 3x. So if you add those together, you get 4x. So it's the first times the first, last times the last, inside, outside, added together. Okay. Let's look now at the next example, problem 18. Okay, here we have first times the first, y squared, last times the last, 21, inside is minus 7y, outside minus 3, that adds up to a minus 10. Okay, first times the first, last times the last, inside, outside. All right, let's take the next one. First times the first, 4a squared. Last times the last, minus 2b squared. A times a is a squared. B times b is b squared. So the first times the first, last times the last. Okay, inside is a minus 2ab, a minus 2ab. Outside is a plus 4ab, so it adds up to a plus 2ab. First times the first, last times the last, inside, and inside is a minus 2ab, outside is a plus 4ab. Adding that together, we get this as an answer. Okay, so let's look at the last example now and talk about this one several ways. All right. To multiply this squared, what does something squared mean? What does x squared mean? It means x times x. So this says, I'll rewrite this, a minus b times a minus b. First times the first, last times the last is plus b squared. First times the first, last times the last is a minus times a minus. Inside is a minus ab. Outside is another minus ab. All right. So if you notice this, when you square a binomial, it's the first one squared, the last one squared, and then it's this times this doubled. This A times a minus B doubled. It's a shortcut method. Special case, if you have a binomial squared, you can just take the first term and square it, last term and square it, and then the middle term will always be this times this doubled. All right, now what you need to do is to work the example problems that follow these notes. Okay, this tape on factoring. It is very important that you have looked at the tape 12 to know how to multiply things together, because factoring is simply in a backward process or a reverse order of multiplying, and you need to kind of remember the multiplication process to double check your work as you go. And let me show you now. Let's look at the problems. Number 1, this is a section on common factoring. Okay, common factor. A common factor says what number are letters, and it could be what number and are letters, that I can divide out. Please listen to that. You're dividing it out. You're not subtracting it. You're not taking it away. You're not moving it out in front. You're not using all this other terminology that people may say. What you're saying is, what can I divide out of here that I can divide out of there? Well, that's 5. So I divide the 5 out. That means factoring it. I'm going to factor the 5 out. If I divide 5 into this, what is left? It's A. If I divide 5 into this, what is left? Or how many times will it go? And it's 1. What most students will make a mistake is they're thinking they're going to take the 5 out in front, and when they do that, they don't leave anything over here. What you're doing is 2 things. Number 1, you're dividing it out of everything. Number 2 is, back to tape 12, if you remove the parentheses and multiply this back together, you better get what you had to start with. That's the way you check your work. You don't have to look in the back of the book when you're working problems like this. What you need to know is tape 12, and that is, multiply it back together. If this times this and this times this gives you what you had to start with to begin with, then you've done this correctly. Again, listen, common factor is, what can I divide out of everything up here that's the same number or letter that I can divide out. Then if there's something that's the same in everything up here, then divide it out and write what is left. And when I say left, what I'm saying is divide 5 into that, and how many times will it go? It goes A. 5 into that goes 1 time. All right, number 2. What is a common factor that's here, that's here? Well, 12. So I will divide 12 out. Dividing 12 into 12, that's 1 time. Dividing 12 into this leaves y squared. Now multiply it back together. 12 times 1, that checks. 12 times that, checks. Common factor. What numbers or letters can I divide out? All right, let's look now at example 3. Problem 3. What numbers, well, there's not any letters, the same letters in both of these, so I can't work with letters yet. What number can I divide out of that I can divide out of that? And the answer is 6. So I will divide a 6. Dividing this by 6 leaves me 5x. Dividing this by 6 leaves me 2. 5x minus 2. What number can you divide out of everything in the original problem If there's some number or letter that's in everything there, then you divide it out. All right, number 4. All right, what number can I divide into 12 that I can divide into 5? Well, there's not one. But here now we have letters. We have a y and a y squared. So we have a y squared over here, we have a y here. So we can take one of the y's out. So dividing y into this leaves the 12 and it leaves me 1y. Dividing this by y leaves me minus 5. Now check your work. What is y times 12y? Well, that's 12y squared. What is y times a minus 5? It's minus 5y. All right, next example. Number 5, problem 5 here. All right, what letters can I take out of both of these? Can I divide out? Well, I've got an x in both of them, so I'll divide an x out. I have a y in both of them, so I'll divide a y out. And now what does that leave me? So if I divide this by xy, it leaves me 1x. If I divide this by xy, it leaves me 1y. What you do is simply say, look, what is it over here that I can divide out that I have over here? Well, it's an x. So I'll take the x out. You could do one at a time. You could take the x out. Then you come back and say, okay, what other letter? I have a y here and y is here, so I'll take a y out. And then what's left is by dividing. Not subtracting, but what's dividing. All right, let's look at the next example, number 6. Problem 6. Now, we look at everything in here and say, what number can we take out of here? Well, a 2 will go into here and here and here, so we'll take a 2 out. All right, what about letters? We have an x squared, we have an x cubed. Well, we can take an x squared out. So, dividing this by 2x squared, that gives us x squared. Dividing this by 2x squared, that gives us a minus 2x. Dividing this by 2x squared gives us a plus 3. Check your work. This times that, checks. This times that, checks. This times that, checks. So we must have done it correctly. All right, now that's common factors. Now let's look at how we factor trinomials. Trinomials. And again, the crucial point of this is knowing the take 12 multiplication part of polynomials was called the FOIL method. To factor trinomials, if they can be factored, then it's going to be a parenthesis times a parenthesis. And this is going to be a binomial. A binomial. We're going to have an x here. I'll just go ahead and write the answer now. We're going to have x here and an x here. We're going to have a 2 here, and we're going to have a 1 here. Okay, in this particular case, it's going to be 2 pluses. Now, they might be 2 minuses. It might be a plus and a minus. But here's how we determine it. This is what I consider to be trial and error method. Instead of trying to figure out some kind of rules that work in all cases, just trial and error. And that is simply the FOIL method. The first times the first better be equal to that one. The last times the last better be equal to that one. And the inside added to the outside better be equal to the middle term. I'm going to say that over and over and over again, and then we'll start working some more problems. I'm saying to you, if a trinomial, 3 terms, can be factored, then one way to find out is the FOIL method. So what you put down is right here and here, something that the first times the first is going to equal to whatever that is. And the last times the last is going to equal whatever that is. And then the inside added to the outside is supposed to equal to the middle term. All right, so let's look at number 8 now and go through this trial and error method. All right, so we have a trinomial. So what we'll try first is this. What times what gives me that? Well, x times x gives me x squared. X times x gives me x squared. Now what multiplied over here will give me 6? Well, 1 times 6 or 3 times 2. So let's trial and error first and find some that won't work just to start out. So if I put a 6 here and a 1 here. All right, now watch all this different things now. This times this, that's equal to x squared. Okay, that's nice. Now this times that. Wait a minute, it's got to equal to a minus 6. Well, let's see. If I put a minus here and a plus here, that'll work. But look what happens. The inside is a minus 6x, the outside is a plus x, and that does not add up to that. This inside outside does not add up to that. Therefore, we must try something else. That's why this is called trial and error. So I'll put the 6 over here and the 1 here. That gives me a plus 6 and a minus. That still doesn't add up. So the 6 and the 1 doesn't work. So now let's go back up here and say, all right, we'll try 3 and 2. So if I put the 3 here and the 2 here, look what happens. The first times the first, that's equal to that. Last times the last, minus times a plus, minus 6, that checks. And here we have a minus 2x and a plus 3x, and that does add up to plus x. So our answer to the problem then is x minus 2 parenthesis times x plus 3 in parenthesis. Trial and error. You just make it work such that the first times the first equals that, the last times the last equals this number, and watch your plus and minuses, and the inside added to the outside better equal to the middle term. All right, let's try the next one, looking at problem number 9. Okay, so what we're going to do is put our parentheses down. All right, x squared is x times x, and 2 is 2 times 1. All right, now pay close attention to plus and minus signs. First times the first, checks. Last times the last. Now that's a plus 2. That meant the answers could have been plus times a plus or a minus times a minus. Either one of them would have worked. But what's necessary is for the inside plus the outside to be equal to this. And now the minus is the one we have to have. This is a minus 2x, and a minus x adds up to a minus 3, and so it checks. So if this last term is a plus, then these two can be minuses or pluses. What determines that is the inside outside. What determines that is this right here. Okay, next one, problem 10. All right, we're going to have first times the first is x times x. Okay, first times the first, that checks. Last times the last. Well, the last times the last is 8 times 1 or 4 times 2. All right, so if I put 4 here, 2 here, now that's a plus, so that means this either has to be 2 pluses or 2 minuses. Well, there's nothing that's minus in here, So it better be 2 pluses. All right, now watch. First times the first, last times the last. That's a plus 8. Checks. But watch. That's a plus 4x, and a plus 2 is a plus 6. Does not check. Well, does that mean then what we need to do is switch the 4 and the 2 over here? No, that doesn't change anything. Okay, well, 4 and 2 doesn't work. Let's try the 8 and 1. If I put the 8 in the 1, that would be 8x, and 1 is 9. It still doesn't work. Now, what that means is sometimes in books, they will give you problems that cannot be factored. The way you determine whether it can be factored or not is this right here. If you can multiply it back together and it works, then you have it factored completely. This does not work. So there are some problems that cannot be factored. And what we'll do is later on is learn how to take care of these by what's called a quadratic formula. But now let's go back and change this so that it'll work. So let's just make this a minus 8 here. And now let's look at it. If we make that a minus 8, now let's go back and try 4 and 2. All right? So if we put plus 4 here and minus 2 here, what happens? First times the first, checks. Last times the last, checks. A minus 2, plus 4. And then the middle term, that's a minus 2x and a plus 4x. And that adds up and it checks. Okay, what I wanted to show by what I had to start with is that not all trinomials factor. Not all trinomials factor. They do. You just don't try to make them work every problem. You just make sure that the first times the first is equal to this, the last times the last with the plus and minus signs is equal to this, and the inside and the outside added up equals to the middle term. If it does check out, then this is the correct answer for the factoring. All right, now let's go to number 11 and look at it. Okay, number 11. All right, number 11. What we're going to do is say, all right, well, this is x and x. We got that. But wait a minute now. 45 has a bunch of choices. We have 3 times 15. We have, 5 times 9. And don't ever forget the 45 times 1. Okay? So let's try the 3 and the 15 first. So we put a 3 here and a 15 here. Okay, first times the first, that checks. Last times the last, that checks. Wait a minute, that's a plus now. So if this is a plus, these two signs are either going to be 2 pluses or 2 minuses. Looking at the middle term, it says that it's going to have to be 2 minuses. Now, what is the middle inside added to the outside? That adds up to minus 18. So that's not the one. So let's go back and try then the 5 and the 9. 5 and it doesn't make a difference what you put the 9 over there or the 5 over here. Okay. Just as long as the first times the first is equal to that, last times the last, minus times the minus is a plus, and the inside plus the outside adds up to this, and it does. All right, let's looking at number 12 here. Okay, we have some x's and y's, so that's no big deal. Just put down the parentheses. Now, what times what gives us 4x squared? Well, we could use 2x and 2x. We could have used 4x and x, but just whatever first times the first is equal to that. All right, last times the last. Now, what gives us 9? Well, that could be 3y and 3y. We could have used 9y and 1y. But again, last times the last, better equal that. Now, if the last sign is a plus, then that means inside here either going to be 2 pluses or 2 minuses, and we go look right here. And so that says it's going to be 2 minuses. And now we check our work. Inside is a minus 6xy, added to another minus 6xy, adds up to a minus 12xy. Does check. So don't let other letters be a problem in here. It's simply the first times the first, better give us that one. The last times the last, better give us that one. And then, if we've done it correctly, the inside added to the outside should equal to the middle term. All right, now let's look at number 13. All right, 13. Wait a minute. Don't ever forget to look for a common factor. Before you start factoring a trinomial, always look for a common factor. We can factor out a 2, and that leaves us x squared minus 10x plus 25. Now, don't forget that. It doesn't mean that you can do it wrong by just factoring to start with. But that's the first thing you should do. Make sure that there's not a common factor in the problem to start with. So rule number 1 in all factoring is look for a common factor. Now after you've taken the common factor out, now look for the FOIL method. So the first times the first would be x and x. The last times the last would be 5 and 5, and again, since this is plus, it's either going to be 2 pluses or 2 minuses. This tells us it's 2 minuses. First times the first, checks. Last times the last, minus times the minus is a plus. Inside added to the outside, checks out. But don't forget, common factor. Always look for a common factor. Now, it so happens that we could have gotten there by factoring like it is. We could have said, well, this would be 2x and x. All right, we would have 2x and x, first times the first. All right, and then the last times the last would have been what? 10 and 5. Okay, first times the first, that checks. Last times the last, that's a plus 50, checks. Minus 10, minus 10 more is a minus 20, checks out. But you're not completely factored here, because now what's a common factor in this parenthesis? In this parenthesis you can factor out a 2. So it leaves us x minus 5. So we get the same answer. It's just that there are some problems later on in this tape where you really need to factor out the common factor first to be able to continue. All right, so here we go to the next one, number 14. Now we're getting into some complicated ones. Same rules, though, and that is trial and error. All right? So, what are the factors of 6x squared? Well, hey, we have a lot of choices here. We can use either 6x and x, or we can use 3x and 2x. So which one do we want to try? Well, we'll try 3x and 2x. Okay, so the first times the first, that's okay. Now 20, a lot of choices here. 4 and 5, 2 and 10, and again also 20 and 1. All right, so what do we try? All right, let's try 4 and 5. So we put 4 and 5. All right, a lot of things to talk about in this one, to pay attention. First of all, this, if the last sign is a minus, then this has to be plus, minus, or plus over here and the minus over there. But If you have a minus here, then one has to be a plus and one has to be a minus. Trial and error, we'll find out which one's which. Okay, last times the last, it's a minus 20. Inside is a plus 8. Outside is a minus 15. That adds up to a minus 7. That's not what we want. Doesn't work. So what let's do is to change the signs and make this a plus and make this a minus. Now what do we get? Minus 8x, and this is a plus 15x, adds up to a plus 7, checks. So we have it worked. Now, listen, if the 5 and 4 hadn't worked, then you would go try 2 and 10. If that didn't work, then what I would do is start over again and start with 5 and 4 here and change this to 6 and 1. But it's trial and error. First times the first, better equal that. Last times the last. And then the inside and the outside added up, better equal the middle term. All right. Let's look now at number 15. And now what we've done is learn how to take care of all the cases. What I want to do by 15 and 16, look at some special things that you factor. For instance, factoring this will be y plus 1 and y plus 1. Okay, y times y, first times the first, last times the last, checks out. But I want you to see this. Whenever you get this factor is the same as this factor, then learn to write that as that. If you come out and these factors are the same, then you write it like this. Now, if you have done the tape 12 on multiplication of polynomials, then, or if you already know this is a special case where you can check your work. If you have a binomial squared, then it's the first one squared, checks. The last one squared, checks. And then this times this doubled, checks. All right, let's look at number 16. Factoring this. Okay, the first one would be y and y. The second one would be 7 and 7. Okay, first times the first, checks. Last times the last, checks. Inside is plus 7 more is 14, checks. So the answer is y plus 7 squared. Okay, which is what? First squared, checks. Last squared, checks. This times that doubled, checks. Now, this could have been a minus right here, and all it would have done is to change that. Okay, still checks. First times the first, or the first squared, checks. Last squared, minus times a minus, plus. This times that's a minus 7y doubled, checks out. All right. That concludes the basic type of problems that you run across on task test in terms of factoring trinomials. What I want to do the rest of this tape now is to look at some special cases of difference of two squares. All right, this section is on a very special type of binomial, factoring a binomial that's the difference of two squares. It's saying where this is a perfect square, something times itself is equal to that. Something times itself is equal to that, which would be 2. Over here would be x. The difference has to be a minus sign. All right, let's say it all again. The first part has to be a perfect square. That means something times itself is equal to that. The last one has to be a perfect square. Something times itself is equal to that. And it must be a minus. If it's a plus sign in here, it will not factor like this. And it's a simple mechanical process. It simply says take that number that takes times itself to give you that, and take that number, which is called the square root of 4. and then one's a plus and one's a minus. Now, it doesn't make any difference whether you write the plus first or whether you write the minus first. It's simply one of them's minus and one of them's a plus. The square of this, first times the first, is equal to x squared. Last times the last is equal to 4. And look what happens. This is inside is a minus 2x. Outside is a plus 2x. Adds up to 0. So what happens is if this is a perfect square, and this is a perfect square, and you have a minus between them, when you do this FOIL method, this factoring process, the inside-outside will add up to 0. You will not have a middle term in the problem. Okay, let's go quickly through several other ones. Look at number 2. We have x squared minus 9. This is a perfect square. This is a perfect square. So we simply write down square root of the first one, which is x and x. Square root of 9 is 3 and 3. And we put a minus and a plus. And again, it doesn't make any difference where you put the plus over there, the minus over here, whatever. Check it. First times the first, yeah. Last times the last, minus 9, yeah. Inside is a minus 3x. Outside is a plus 3x. Adds up to 0. No middle term. Checks out. All right, looking at number 3. Perfect square, yes. Minus, yes. Perfect square, yes. So what we have is x minus 7 and x plus 7. First one, last, inside, outside, adds up to 0. All right, look at number 4. Looking at number 4, perfect square, yeah, that's 4, and that's x squared. Perfect square, yeah, that's 1. So then this will be 2x plus 1 and 2x minus 1. First times the first, yes. Last times the last, yes. Inside is a plus 2x and a minus 2x. Adds up to 0. Checks out. So if you have a binomial, that's two terms. It's the difference of two perfect squares. Then it's the square root of the first one plus and minus square root of the second one. All right, let's continue now with some other examples that just look a little different. Still the same rule. Looking at number 5, we have perfect square. Yeah, that's a perfect square. What that is x cubed times x cubed plus 3 and minus 3. Remembering now, x times x, you add exponents. So if this number right here is a 2, 4, 6, 8, 10, 12, 14, an even number, if the power is an even number, then that's a perfect square. And you just divide it by 2. First times the first is x to the 6th power. Last times the last is minus 9. Inside is a plus 3x cubed. Outside is a minus 3x cubed. Adds up to 0. Checks out. So it doesn't always have to be a 2 here. What it has to have is a power that can be divided by 2. And then you just write those down. All right, looking at number 6. Okay, number 6, 36 is 6 and 6. 49 is 7x and 7x. Plus and minus. Again, it doesn't make any difference where you put the plus here and the minus over there. Middle term, plus 42x, minus 42x. Adds up to 0, checks out. So it doesn't always have to have a 1 or just one of these numbers being perfect square. As long as this is a perfect square and all of this is a perfect square, separated by a minus, then you can do this process. All right, let's look at the number 7. And again, same thing. This is a perfect square, and this is a perfect square. So this is 4 plus and a minus. All right? Square root of x squared is x. Square root of y squared is y. So it's xy. First times the first, that checks. Last times the last, what is x squared? Xy times xy, it's x squared, y squared. Okay. Middle term is 4xy's and a minus 4xy's. Adds up to 0, checks out. All right, now let's look at the last one. And again, do not forget, do not forget, do not forget, common factor. Always look for a common factor. This is not a perfect square. That is not. You cannot take the square root of 2 and get an integer. Can't take the square root of 50. But we have a common factor here. We can divide a 2 out of that. It now leaves us x squared minus 25y squared. Now, this is a perfect square, and this is a perfect square. So we now finish the problem with x minus 5y and x plus 5y. Okay, so there's some problems that when you take the common factor out, then you can use this special rule. Checking that first times the first, last times the last, checks, middle term drops out, so it works. So here's what I wanted to caution you about. When you have a common factor, factor it out, but don't stop there. Now check what's left to see if it can be factored. All right, this concludes then the tape on being able to factor some very basic binomials and trinomials and common factors that should help you.